So this is the formula that you can do any kind of calculation with this. Our next topic, which is data types. Okay, so how data types are working? There are like a lot of data types in the Rust, which I will not list down here. You can just go to like Google and you can Google it out. But what I will do is to tell you how these data types are being interpreted in the memory and how this is happening, all the things under the hood. So let's have a just stop the debugger and back to our normal execution and start with the new topic, data types. So there are plenty of data type. If I just have a comment here and ask the copilot, it will type it for you. So if I show you all of the data types, here's the copilot just typing for us. It's the like a lot easier for us now, and these are all the integers that are unsigned in things, and this is the floating point. And here there should be another one, bool, and it should type another one which is called, let's type char. Yeah, char or char, whatever you want. So these are the primitive data types, and Rust have two kind of like data types. One is scalar and the other one is compound. Rust call it scalar. Most of the other languages call it primitive, kind of primitive data types, which is all primitive or scalar means the language which the language already and natively have. So the base data types. So these are the primitive data types, and the other one, uh, let me type it out here. Two kind of data types. Um, the first one is scalar, and the other one is compound. And what the scalar or primitive are, this is the just base data types that a language have, and the compound data types are the types which are produced or created by combining the primitive data types. So I will talk about it a little bit later. So let's have a look at scalar types. So all of these data types, like in the first row, it is all I, like starting out with I, and this I mean integer of type of size this 8 bits, integer of type 16 bits, integer data type of integer type size 32 bits. Like you can store also signed and unsigned value. You can also store negative and positive values in these kind of data types. And at second line there is U8, U16, U32, and all these kind of like data types, you can only store unsigned values like positive values. This U mean unsigned and unsigned mean non-negative values. And what this I size and U size mean, like most of the time as we are doing now, we are not like mentioning any kind of data types with the variables. And what uh, operating system does is operating system automatically pick up the data type according to your architecture. If it is of 64 bits, then what the operating system do or the compiler do is like detects the type of your operating system and just automatically assign the data type of that size. Like if your operating system is of 64 bit, then it will assign I32 or I64 or F64 or U64. And if your architecture or operating system is of type I32, like not I32, 32 bit, sorry, what compiler will do is automatically assigned of type I32 or U32 or float 32. So this is what I size and U size mean. And if I go to float, this F mean float 32 and F64 mean like you can store the float value up to 64 bits. And this at that like fourth row we have bool, and that at 5 we have character. So to explore, like there is some kind of things like you might be a little confusing, like how many kind of combinations are, how much long like digits or numbers this data type can hold. So let's do some math, and let me go to our whiteboard. So let's suppose you have a data type of U8 which is unsigned 8 bits, and what this U mean unsigned and 8 mean 8 bits, or you can just simply say 1 byte. So let's suppose a variable x initialized with this data type U8, and now you want to check like how many kind of combinations or how much long integer you can assign to this data type. As it is unsigned, so you can only save non-negative digits here, like you can save -2 here. So this can only hold this x can only hold the positive numbers. So okay, to calculate the size of this data type, there is a simple formula which describes 0 to 2's power n minus 1. This is the simple formula. Just replace this n with this 8 and you go 0 to 2 minus 2's power 8 minus 1 is equal to 0 to 256 minus 1, and then what we have is, or straightforward, 0 to 255, yeah, 256 minus 1, 255. So like why this 255 is here, not 256? Because we are not starting from 1. It is not from 1 to 256 because we are also considering 0 here. That's why we have to minus the 1 number from the end. So that's why we are doing the -1 here. Okay, so this is for U8, and but what if you want to like just to calculate for I kind of data types, integer 8 bits. So this is the simple integer of 8 bits, and for formula for this is, as this data type, let x of data type I8, as this data type can hold also minus and positive numbers, so there will be a range from negative towards positive numbers. So the formula this for this kind of data types will be minus 2's power 2's power n minus 1, and then at 2's power n minus 1 minus 1. Yeah, that I think this is the formula we can calculate on it. So let's suppose we are calculating on I8, and minus 2's power 8 minus 1, it will be 8 minus 1 minus 1, so it will be around minus 2's power 7. What 7 will be? I think 128, and this will be, yeah, 128 and minus 1, it will become minus 128 towards let me shift it out at a little up. It will become minus 128 to 127. Yes, this is range minus 128 to 127, because we are also considering at some point of this range 0, so that why we have to like minus at the far end the 1 digit. So this is the formula that you can do any kind of calculation with this. So this was all for the data types, and this is same kind of like arithmetic operations as some of the other languages have. Like they have plus operations, they have subtraction operations, and yeah, this is this is the all Copilot just typed here. So these are all the arithmetic operations that you can like straightforwardly have here. The one issue that you can face is wrap up issue. Wrap, not wrap up but wrap around issue. This is like major issue in this programming, but this is resolved via some of the crates, some of the packages that you can use, some of the methods. So what this issue is, like whenever let's suppose you have a variable x is equal to x of u8 is equal to 255, and let's suppose I am just x is equal to, let's make it mutable, and what I do is x is equal to x plus 1. Now let's guess what the value will be if I print it out here. So if you are considering like this value will be somewhere at 256, then you are wrong, because this value is not going to be 256. Instead, this value is going to be, let me just run the cargo run command. Oh, I think I am not in the right directory. Yes. Let's change the directory here, episode, and then just run the cargo. Panicked, yeah. Tempted to add the overflow. Yeah, this is the thing that I wanted to share with you. So it's being what it's doing is it's creating a panic here, because you can't add one uh, in the X. Because why? The reason is you have U8 data type here, and U8 have a range of 0 to only 255. So if you will add one additional one here, what it will do, it will just wrap around and it will go to 0. And there are some of the methods to to avoid from being panic the program. So you can just wrap around, and when you will add the one, this X will go to 0. We will discuss these methods in the later videos, like what are these methods, and these methods are like really helpful whenever you have a fear of like wrap around things that values might be some mismatched. So you can use these wrap methods, and this will make the things a lot easier, and it will not cause the program to be panic. So this was all I think with primitive data types. And now what we have is like this is the same with the float data types, F8. You can explore this out in some Google Docs. I will share the link with you. Let me share the link here if you have to explore it out. So here's the link, and one thing we are missing is the character data type. Let's have an example of it as well. Char, and you can store any kind of character in this. So this is a kind of character data type. Oh yeah, this is an array of characters, but you can only store one character via single quotes, not double quotes. Yeah. So this is a character data type. We'll discuss what we was getting like facing the error here. It was of double string. This is not a character data type. This is a string, and we will explore this much more in the detail, because we have two kind of strings. One is this thing, and the other one is of we have already used this one, new string data type. So we'll explore these things out in the later episodes. So this is a character data type which can hold and by the way, this is of size 4. Each of the character data type will hold 4 bits of the code. 4 byte of the code will take a space of 4 bytes in the memory. So this is the character data type which can and what the special thing about Rust character type is, you can not only save the characters, but you can also save some of the emojis here. Like if you want to print out some emojis, you can also store it, because this is a Unicode character type. This is not like simple scalar character type. This is a Unicode character type, and this can hold hell a lot of things. Like you can enter any kind of Chinese character here, any kind of language here, and you will be just it will be just printed out in the console. By the way, if you will try some other language out of the English, like Chinese or Mandarin, I think what was the name of the language. So uh, what will happen is memory size will not be the same, because these languages behaves in some different way. What in English happens is if you type some W or E here, like W here, what's happening is this is only the W. To get the W, you just have to type the W. But in some other languages, to get some output, you have to type some double number of things. Like you type some 2 characters, then you get output of the 1. So when you type 2 characters, this will occupy more space, and the space taking the space mechanism with some other languages like not computer languages but some speaking languages, which you will type some other kind of Chinese here or some other things. So the memory taking mechanism will be the totally different. So it will not always be the 4 bytes. Just keep in mind this thing. So now let's move toward the next compound data type. So Rust natively support two compound data types, which is tuple and the other one is array. So Copilot helped us. One is the tuple, which is the native compound data type in the Rust, and the other one is array. So let's explore what compound mean. Is actually you blended more than two types of the primitive or scalar data types and you make one compound data type. Simple as that. Let's take an example. If I take example of tuple, and I create some tuple kind of this. These are too much long. Let me have a smaller one. 1, 2 and 3. Yeah, this is the tuple. And the amazing thing about tuple is now you have all of the data types of same, like i32, i32, i32. But the amazing thing is that you can also have the float here as well, and this will be spotted. Now you see the compiler, what compiler reduce the types i32, f64 and i32. So this is the totally completely changed data types here. And if I want to have values from the tuple, what I can do, there are two, like there are a lot of methods, but there are mostly two used. One is the famous one, destructuring. What destructuring mean is you just type this thing and all of the value of this tuple are just being saved in these variables, and you can just simply printed out these variables. If I save and run the cargo run command, and all of the variables will be like printed out at the screen. I think character is giving some hard time. Let's comment out and then again run cargo run. And yup, this is also panicking because there was an overflow issue. Now it's all good, I think. Yup, and run the cargo run again, and yeah, you just go with these values at the console. So this is with the character, not with the tuple. And you can also access, if you want to access tuple values one by one, you can do that via this way. Like you can type the name of variable and then 0, because each of the values are indexed at 0, 1, 2, 3, just like an array. So you can access the values via dot and then mentioning the index of this value. And let's now move towards, I am just fastly um, going through all of these data types because there is not like deep concept in these things. So the next thing is array. And array can contain only single kind of data types. Like unlike tuple can contain multiple kind of data types, like this is i30, this is f64, this is i32. But arrays can only hold single kind of data types. Let's take an example. Let's what will be the name of this? Let's take its array 1, and this can be 1, 2 and 3. And let's save it out, have a semicolon here, save it out. Here compiler is not complaining anymore. And if I accidentally typed 3.2, this will give a error here, warning here, compile from the compiler side, because you can't have multiple kind of data types in the array, so you can only have single kind of data types. So this is all with the array. You can iterate them via loops. We'll be discussing these in the future. You can access it via index, like array 1 of at index 0, or some kind of whatever the index you want. By the way, one important thing, you can also initialize array via mentioning the size here. Like you want index of array of 3, only 3 size. What you do is mention the size here 3, and you also want to mention the data type, and you mention the data type here i32, and this can be of any type like f32 or any kind of data type. But we have the values of i32, so I will mention i32. By the way, and the other thing is that you can't change the size of array. These arrays are static. If you want to add something, like if you do some array2 dot push or push or some kind of, you want to try to add something here, this will, compiler will not allow you, because these are fixed arrays, because you have already mentioned the size here. And if you, even if you don't mention the size here, this is stating that what you have already like initialized this variable from three size of array. So this array will keep its size, maintain its size throughout the code of three size of array. So you can change the size of array, but we have it another data type which is called vector. We'll discuss it later. And vector handles the like size in a very pretty much awesome manner. You can change the size of a vector. So at the end, let's take an interesting example from the like array side. Interesting array example. What this can be, this is to show you out of bound errors, how Rust beautifully handles out of bound errors. So let's say you have you take some input from the user via using IO library, IO stdin read line. Let's give some intelligence from this, and let's define the variable guess here, which can be of like string type, that we already did this in the previous example. Okay, so guess is being saved, whatever the value user will type from the console via IO input output library is being saved in this guess variable. And this aspect, as we already discussed, this is just handling the panic behavior. If user some typed some of the like not allowed value, some kind of like not the digit or not the valid value, so this program, instead of panicking, this will nicely handle the error and will say fail to read the line. Or you can just say any kind of error that you want to say. Please input valid input stuff. Okay, so let's save this in the guess, and just trim the guess a little bit, and then just move ahead. And what to say is, let's say, and now ahead, what you try to do is you try to have array val access the array value at a wrong index, array of guess. Let's suppose we are accessing this array value at some of the user input index. Let's run it and check it by example. Let's just comment out it here, and have this way it's being thrown. Yeah, let's have some expect here to nicely handle this. Please not good input. Okay, let's just save it out. Now it's not complaining, and why it is complaining is that I think this is due to cannot find value array1 in this scope, not found in this scope array1. Okay, I just commented it out, my bad. So let's uncomment it. Now it is accessible, and now guess is throwing the issue because there is a mismatch typed issue. Okay, if you see what's happening here is so the error is the type cannot be indexed by u32. The trait is not implemented for u32. Trait is implemented by use size required for integer to implement index. So it is complaining about the type error. So what we have to do is now to just change the value use size, the type of this guess to just use size, and this complaint will be gone. And now also we have to do this use size, not use size here, but so also this is throwing error here. Why this is throwing error? Mutable. Okay, so we didn't make it mutable, we have to make it mutable as well. So now it's not complaining at all. So let's run this out, cargo run, and what it is doing here is just waiting out for our input. So let's give the index which is not existing in this array. So this array have 0 1 2 index up till only 2. So let's give the index 4. If I give the index 4 and hit enter, so this thread is panicked at index out of bound. So the program will not crash Instead, the program will be panicked at this line, saying you the error, giving you the error that this is not the correct index that you have just typed. Please type the correct index. So this is the behavior that Rust gives and handle very nicely, which other languages don't do. It is not crashing out entire program, is just panicking at some of the line and telling you that please give the right index which is not out of the bound. So this is for array, I think that you can just practice it out at the home with some other kind of twist. So this is for the array, and hope you enjoyed the episode, because this was a pretty much long episode, I know, but all of the value, all of the like information, all of the stuff was very valuable, because we have just seen all of the things under the hood how they are working. So this is for this episode, and see you in the next episode with the some most interesting episode which is going out and which is my favorite, and see you in the next episode. Till then, bye bye.